If you're developing applications in a Kubernetes environment, you might know how challenging it can be to manage the development cycle. Each time you make a change in the code base or configurations, you must build, test, and deploy the application to see the results. This process can be tedious, time consuming, and error prone, especially when you're dealing with multiple microservices and dependencies. This is where Scaffold comes in handy. Scaffold is a command line tool that automates the development workflow and provides a streamlined way to build, test, and deploy applications on Kubernetes. With a scaffold, you can focus on writing code and let the tool handle the rest, including building and pushing Docker images, deploying and updating resources, and streaming logs for debugging. Scaffold supports a wide range of programming languages and frameworks, and it integrates seamlessly with your existing development tools and workflows. Whether you're a developer, DevOps engineer, or IT professional, a scaffold can save you time, effort, and headaches and help you deliver high quality applications faster. This diagram shows what a scaffold can do to make life easier for developers. Scaffold is a command line tool that automates the development workflow for Kubernetes applications. It can do the following things. It can watch for changes in the source code and automatically rebuild and redeploy the application. And it can also build and package application artifacts such as Docker images. And after that, it can also push application artifacts to a container registry. And finally, it can deploy application artifacts to a Kubernetes cluster. Scaffold also has built-in support for various development scenarios such as local development, remote cluster development, and continuous integration, continuous deployment CI/CD pipelines. Additionally, it supports multiple development profiles so you can easily switch between different configurations depending on your needs. Scaffold is a powerful tool for simplifying the development and deployment of containerized applications. It automates many of the repetitive tasks involved in building and deploying containers, allowing developers to focus on writing code rather than managing the infrastructure. It can help in building container images, restarting containers, deploying containers to Kubernetes, and cleaning up the resources. By using Scaffold, developers can streamline their development workflow, making it faster and more efficient to build and deploy their applications. Additionally, Scaffold is cloud agnostic and can be used with a variety of container orchestrators, making it a versatile choice for teams working on different cloud platforms. Scaffold is a tool that abstracts away the specifics of the cloud platform or container orchestrator being used. This means that Scaffold can be used with a variety of cloud platforms such as Google Cloud Platform, GCP, Amazon Web Services, AWS, and Microsoft Azure, as well as with different container orchestrators such as Kubernetes, Docker Swarm, and Nomad. For example, if a team is using Kubernetes to manage their containers on GCP, they can use a scaffold to automate the build and deployment process without having to worry about the specifics of Kubernetes or GCP. If the team later decides to switch to a different cloud platform or container orchestrator, such as AWS or Docker Swarm, they can continue to use Scaffold to manage the build and deployment process without having to change their workflow. This flexibility and versatility make Scaffold an attractive option for teams working on different cloud platforms or container orchestrators. Now let's see how we can install and use Scaffold in our local development environment. I assume that you're using Minikube and it is installed. Here is a brief review of the commands that we're gonna use in the example that follows up. First, we will install the scaffold in our platform using brew install scaffold command for Mac OS users, and for other OSs, I will show you how to install scaffold. The second command is used to start a Minikube cluster with the name custom. This is a custom profile for starting our Minikube. This is just the name of our profile. The third command is used to set the default context of Scaffold to use the local Kubernetes cluster. The command number four is to set up the local Docker environment to use the Docker daemon running in the Minikube cluster with a profile named custom. And the scaffold init command actually initializes a new scaffold configuration for the project and generates a scaffold.yaml file based on the detected source code and selected options. And finally, Skaffold.dev. This command is used to build and deploy our application continuously, providing real-time updates and streamlining the development workflow. And the set of commands in number seven is the commands that we usually use during our microservice developments using Minikube. And I will show you how to use them and when to use them. To install a scaffold in your workstation, you need to go to this address scaffold.dev docs install, and you will see a comprehensive guideline on how to install scaffold for various operating systems. For example, for Linux OS, you can find stable versions of a scaffold for different architectures, and also you can find the latest version of scaffold which is built from latest commit in these two links, or you can use these options to install the scaffold in your Linux environment. For macOS users, there is also this option, install the downloading binary files and installing them, or you can use brew to install scaffold. And for other OS, Windows, Google Cloud, and Docker environments, you can also find how to install scaffold. Okay, using brew install scaffold, we can install the scaffold in our OS, and after that we are ready to use the scaffold, minikube, and kubectl commands to set up our development environment. And to do so, let's first of all show you the structure of the project. In this project, I have 5 microservices. One microservice is based on Django, the other one is based on Node.js. I have a RabbitMQ microservice and 2 database microservices based on Neo4j and Postgres databases. And inside each of these microservices, there is a Docker file and also Kubernetes YAML files to actually configure and build the microservice. And these are just the files that I use during the development, and I usually manually create the images and deploy images to Kubernetes. But after getting familiar with Skaffold, I usually, most of the time, use Skaffold to actually make the development process easier. So these are just the simple projects. Let's go up, and now in the root of the project, we can run scaffold init command to initialize a scaffold.yaml file for our project. But before that, we should set up the minikube and also set up the scaffold to use the minikube and kubectl. So let's do so based on the steps that you saw in the slides. So let's first run minikube with a profile named custom. It takes some time to initialize the cluster. After that, we should use scaffold config command to tell the scaffold to use the local cluster that we are creating right now. And it is just going to finish. Okay. Now we are ready to use scaffold config set dash dash global local cluster true. And after that, we can use eval command to set the Docker configs, Docker environments. Now we are ready to use the scaffold init to initialize the project. And as you can see, based on the project, scaffold asks you some questions. For example, the first question is choose the builder to build image Collabshare RabbitMQ. RabbitMQ is one of our microservices, and Scaffold wants to know which of the following Docker files is used to build the RabbitMQ image. So I chose the appropriate builder. And for the Django, this is the Docker file, and for the graphs microservice, I use this one. This is the Docker file for building our graphs microservice. As I said, you should choose the builders based on your microservices. And for the Neo4j graph, this is the file, and for Postgres microservice, I use this file. And finally, I click, I enter and accept the configuration, and all the configuration will be written in the scaffold.yaml file. So if I use ls, now you can see that there is a scaffold.yaml file that. Now let's open the project in Visual Studio Code to see the scaffold.yaml file. As you can see, this is a configuration file that is created using scaffold command for our project. These are the Docker images, Django graphs, and these are the Kubernetes YAML files for each of the microservices. At this time, we are ready to run the scaffold dev command. And it takes some time because it should create images and the whole process of setting up the Kubernetes. So it takes so much time. Okay, now as you can see, everything works smoothly and all of our microservices has been built successfully. Now let's change one of the microservices, one of the files. For example, let's change the settings of the Django project, and we set the debug to false. Save the results, and immediately the scaffold detects the change and rebuilds that microservice and initializes the pods again. And as you can see, these are all the logs related to the Django project. So in conclusion, Scaffold is a powerful tool that simplifies the development workflow by automating repetitive tasks involved in building and deploying containers. It is a cloud agnostic solution that can be used with a variety of container orchestrators, making it a versatile choice for teams working on different cloud platforms. The scaffold dev command is particularly useful as it automates the build and deployment process, allowing developers to focus on writing code rather than managing the containerization process. Additionally, Scaffold can integrate with many other tools commonly used in the development workflow, such as Kubernetes, Helm, and Docker. And so it makes it a valuable addition to any development team's toolkit. Overall, Scaffold is an excellent solution for streamlining the development workflow, making it faster and more efficient to build and deploy applications. If you need further information about Scaffold and how to use it more efficiently, or configure it based on your project's requirements, you can go to scaffold.dev docs and learn more about this wonderful and handy tool.